Welcome to the video on the Pearson Product-Moment Correlation. Let me get this up on the board. Pearson Product-Moment Correlation. You may also hear this just referred to as the Pearson's R or Pearson's correlation, but the Pearson Product-Moment Correlation. So this was created by Carl Pearson, late 1800s. And let me get the formula up here, and we're just going to kind of break this thing down. So the basic structure here is it's that R coefficient, so R equals this S term sub xy, and I'll define these for you in just a minute, divided by S sub x multiplied by S sub y. Let's talk about what these are briefly here. It's called the product moment correlation, and so this top piece here, the S sub xy, is really the covariance of variable x and y, or the covariance between or of variable x and variable y. And this S sub x multiplied by S sub y is the cross product of the standard deviation of the x and y standard deviation of variable x and variable y standard deviation, and just abbreviate that. So you can almost think of this as, you can put parentheses around this and say the standard deviation of variable x and multiply by the standard deviation of variable y. So we know how to get standard deviation. So we already know how to get the denominator. We can go all the way back to the videos on standard deviation. We know how to get the standard deviation of variable x and variable y. And you see I've pre-listed data in here. I've listed the same data for the random variable x, which was years of service for, of employment that you've had in your particular job for 10 different individuals. So when I equals 1, the person served 7 years. When I equals 2, the person served 8 years, and so on and so forth. So that's looking at this particular column right here. So how do we get this this numerator piece, this S sub xy? Let's just break that down. So S sub xy equals the sum. This is where the product moment piece comes in for the Pearson correlation. The sum of the x minus x bar multiplied by the y minus y bar divided by n minus 1. So once you solve this, you'll go ahead and bring it all the way up. Then it will come, and I'll just make a circuitous path here. Whoop. Let's bring our, sometimes when I hit that button on my pen here, it makes everything go crazy. So you get this value, it will come all the way up here and become the numerator. Excuse me. Alright, so what is the x minus x bar? This piece right here, let me highlight it in red. This x minus x bar piece right here, we'll call A, is this piece right here. And let's do the other one in green, and this y minus y bar piece right here is going to be, we'll label it B, and that's going to be this piece right here. Well, what are these? Going back to the moments of the mean video in this particular module, these are the first moments of these deviation scores away from the mean. So it is essentially a cross product, summing the cross products of the first moments of variable x and the first moments of variable y. Okay, so we're going to have to calculate this as we go along. So to recap, what data do I have up here so we can actually calculate this? Again, I have this x data that we have dealt with already. And so how did I get this mean value that is right here, this x bar of 6? Okay, I'm just going to do this in steps. We'll call it step 1. I calculated my mean. What was my mean? My mean was the sum from I equals 1 through n of the raw score. So I'm summing all of the x sub I scores and dividing by the total number. So this gave me 60 divided by 10, which equaled 6. Brought that up here into the mean column. So that was how I got x bar. Step 2, I need to calculate my sums of squares. How do I get the sums of squares for variable x? Well, it's the sum of those x minus x bar scores squared divided by, or sorry, no divided here, it's just sums of squares. That's where I'm going to stop with just sums of squares. So we're just going to take and sum this particular column right here. What do I sum to? I sum to 66. You can plug and chug those numbers on your own in your calculator. What's step 3? I'm gone from the mean and 1 to step 2, the sums of squares. Step 3 then was to calculate variance. Well, what's variance? The variance of variable x equals the sum of the x minus x bar squared, which was our sums of squares component, now divided by n minus 1 equals 66 divided by 9 gave us 7.33. Again, plug and chug those numbers to make sure they're correct. Then step 4 was to get the standard deviation denoted by just s. So s sub x equals the square root of s squared of x, which equals the square root of 7.33, which gave us 2.71. Okay, and so that gives us the standard deviation. So if I was now to actually, I'll go back, instead of putting that in a yellow box, I'll put it in a blue box. This piece here will now come up. If you're going up here to the equation in R, I'll put a box around this. It is now going to give us the first part of this cross product piece. So now we have to figure out, and I've left some of this blank so we can kind of do it together as a recap. So we have to find now, and I'll put a squiggly line here to break the calculations for variable x up from variable y. So let's get the mean, first step, of y. So I've got these paired data. So for all 10 cases here in the x sub I column, I've got corresponding data for them in the y sub I column. And if this is years of service, this might be years of work experience they had before they got to this place of employment. So x sub I is years that they've served at their current place of employment, and y sub I might be years of that they had work experience prior to coming to their current facility. And so let's find the mean of those years of experience prior. So to do this, again, we're going to sum from I equals 1 through n. Now the yi raw scores divided by n, which will give us a sum of 40 divided by 10 equals a mean of 4. So I transfer that mean here now to these 10 scores. 6, 7, 8, 9, 10. And now I'm going to take yi minus y bar, so this will give me 0 here, 1 here, -1, 3, 0, -3, -1, -2, 2, and 1. Now if we square these, what do we get? So this is now the next column, y minus y bar squared is going to, 0 squared is 0, 1 squared is 1, -1 squared is +1, 3 squared is 9. 0 squared is 0. Negative 3 squared is positive 9. Negative 1 squared is 1. Negative 2 squared is 4. 4 and 1. Okay, I'll actually create another little squiggly here and kind of you'll see what this is going to be here for in just a minute. So let's calculate then step 2. Sums of squares for variable y equals the sum of the y minus y bar squared, and the sum of the y minus y bar squared here would give us 30. Put these in boxes here. Third step, I need to get the variance s squared of variable y equals the sum of the y minus y bar squared divided by n minus 1. So it's just going to be this 30 divided by our n in this group, which was 10 minus 1, which is 9. 10 minus 1 equals 9. And 30 divided by 9 gives us 3.33. And to get the standard deviation, which is step 4, we're going to take the square root of the variance of variable y, which is going to be the square root of 3.33, which will give us 1.83. And instead of putting that in blue, I'll put it in, let's do red, and put it in a red box. And that gives us now up here in our variance, so we're going up here to the equation for r. That gives us the second piece here, which is this box. Okay, so we've got the whole denominator piece worked out, which is the cross product of the x and the y standard deviation coming from step 4 in the blue and the red boxes. So now we need this s sub xy numerator piece, which is again this particular equation right here. So how do we get that? Well, we've got to have this cross product of the first moments, the cross products of the first moments. And so what I'm going to do here is just kind of separate this out and create a little column here that is the cross product column, which is going to be the x minus x bar multiplied by the y minus y bar column. So what does this mean? We're going to take the moment, the first moment in the first case for x. Let's do all this and let's do it in pink, okay? So it's going to take this one here, which is the x minus x bar, and multiply it by this 0 here to get a cross product over here. 1 multiplied by 0 is 0. Okay, let's do the next one in this teal color. So now we're going to take 2 multiplied by this 1 to get a cross product of 2. And let's go back to red, this 2 by this negative 1 to get a negative 2, and so on and so forth. So let me just go back to yellow and we'll fill in the rest of these. I think you get the intuition. So the next one would be 3, and then we get a 0 again, then a positive 15, and then a 0, and a negative 6, and another negative 6, and a 2. Okay. And so what does our equation over here say? It says this equation right here, s sub xy, says the sum, that cross product column. So if we sum this column, you're going to get positive 8. So sum here equals 8. And we want to divide by n minus 1. So this over here is not a question mark anymore. It's going to reduce to 8 divided by 9, which is going to be 0.89. Okay, so n minus 1, which is still 10 cross product scores. 10 minus 1 is 9. Alright, so now we've got the numerator component, and we just need to kind of plug and chug our numbers. So again, We go to R equals this S sub xy number, which is 0.89 in the numerator, and then we're going to put that standard deviation for x in, which is in this blue box down here, right here, which is 2.71, multiplied by the standard deviation of y, which is in this red box right here, 1.83. So this will then reduce to 0.89 divided by 4.96, which equals to 3 decimals 0.179, which you could then round to, say, 0.18. And that would be your R value. So then we would have to give meaning to this R value. Remember that R can range from negative 1.00 to positive 1.00, and anything that is a 0, when R equals 0, there's really no correlation. And so we would say that, you know, this is a fairly weak, or rather weak, correlation between this X variable and the Y variable, or the number of years that you have served at a particular employment place versus the number of years of experience that you had prior to that employment place. And so that's the full hand calculation of the Pearson Product-Moment Correlation. Again, Carl Pearson's creation, and it's this concept of covariance of X and variable X and variable Y divided by the cross product of their respective standard deviations. The math of it is actually very simple once you kind of define the terms and understand where everything's coming from. I hope you enjoyed the video. Thank you.